This time I have an old Sanyo security camera. Now this would have been an early CCD camera. Most security cameras of the era were still using a Vidicon tube, and then the CCD quickly took over because no burn-in issues, better reliability, better sensitivity, sensitive to infrared. Lots of advantages. This is an early one. It would have been a relatively expensive, high-end security camera back in the day. Let's check this one out. This is a Sanyo CCD security camera. I would imagine it's probably black and white. Made in Japan. I don't know anything about it. It was given to me. I was told it doesn't work, so I would have to assume that it does not work. It's got an external iris on the lens, as you can see. So there's a cable that plugs around to the back for the iris control. And on the back you've got the lens iris control, horizontal line phase, and normal gain or high gain. Video out and external sync in. Now that may have meant that this could have been used, for example, in a TV station as a graphics camera for shooting graphics, and they needed to synchronize it with the other cameras in the station. That was one of the things that external sync was used for, so that it could be used as a keying camera for keying graphics. I don't know if it works. I'm told it doesn't work, and that's why it was taken out of service. So we're going to take it apart and see if we can make it work. Now this camera does not require 120 volts. This is low voltage. So here's a transformer. 24 volts AC, 20 VA is the output. This is the transformer that actually I got with the camera. So we're going to hook it up to power it up, and see whether we get a picture. That's for starters. And I don't think we will, because I was told it was broken. So then we'll dig into it and see if we can figure out what's wrong with it. I was supposed to have a Macintosh amplifier come in today, receiver, but unfortunately I had to postpone with the owner because, well, I'm still under the weather and I don't want to pass it on to them. Unlike that a-hole customer I had last week, that getting their goddamn internet up and running was so important to them that they just didn't bother to cancel. So they brought me into their house when they were all sick, knowing that they were sick because their kids were all home from school sick. And the whole family was sick, and rather than cancel because their internet was so important to them, that they brought me in and made me sick. And then when I kind of gave them hell for not canceling, I got a bad review, if you can believe that. Almost makes me tempted to want to go over and cut their service off for them, but can't do that. But it's the thought that counts, right? And then when they call to get it hooked up, the guy won't come out and hook it up for them. Be coincidence? Maybe? They would say that. They would say it's a coincidence. It's like a story a number of years ago from my days of splicing, where we were doing a cutover, and probably shouldn't tell this story, but let's just say that the crew got their vehicles impounded, and well, I'll tell you the story. Yeah, this thing's got no picture. It's got power. I got power here, and I got no power light here, and it's got no picture. And I'm sure that this transformer is putting no power. This is plugged in, so I do have power on this adapter. Anyway, no, the story goes, crew was working on a late night cutover. It was taking place at like throughout the night on a Sunday evening, because when you're doing cutovers, it has to be done during the window. And I wasn't part of this, but the crew that I was working with was. But they worked all night, and they all decided to go for breakfast at the end of their shift, because they worked from like 11 o'clock at night till 7 in the morning. And they decided to go for breakfast at an all night or early morning probably Denny's or one of those places, or IHOP or something that's open all night. And they all park their cars in a lot. You know, it said reserved parking 24 hours a day, but this we're talking 6 o'clock in the morning on a Sunday morning, or 5:30 in the morning, or whatever. They finished up and they were going to go and have their break. And anyway, they came out after going in there for, you know, half an hour, 45 minutes, having their break and their meal. They all came out and all their trucks were towed away. They were impounded. And apparently all the phones went out at the towing company, and they couldn't get anybody out to fix them. One of the guys said, yeah, someone said that was a coincidence, and the joke, the punchline was, yeah, that's what they said. It's just a coincidence that they towed away all the guys' trucks, and their phones all went. Now these guys are all long retired. This happened like 20 odd years ago, but these guys are all retired. But I still remember that one to this day. Yeah, don't piss off the phone guys. Like, don't tow away their trucks. You know, but shenanigans, right? Looking for my meter. I know it's here. Oh, it's right in front of me here. You see, I got flu brain because I've been sick all week. Well, not all week, but it's been coming on for the last couple days, and it really hit me yesterday. We got 27 volts here, so AC, which is about right because 24 volt transformer, but you know, it'll vary a bit depending on the input. So we do have power, but this thing don't work. There's no video output, there's no power light, there's no nothing. So we need to take this thing apart and see why it's not working. Excellent. How does this thing come apart? There's screws on top and bottom. I guess we'll just start removing screws. I don't even know why I want to fix this thing. I don't have a use for it. Well, maybe I'll find a use for it. I don't know for what, but let's just see how bad it is. It's probably bad. Like it's probably really bad inside. Like, I'm gonna go out on a limb and say it's full of surface mounted caps and they've all puked all over the circuit board. Do you think I'll be right? Could be. Could be very right on this one. We'll see here. More screws on the bottom. There's the CCD on here. It's obviously a monochrome one. It's a silver. There's no color filter on there, so you see the chip itself is silver. Why is this top not coming off? This top should lift off. Anyway, when I took this one down, they just said, yeah, you want to take it away and get rid of it? Okay, I'll take it away and get rid of it. And now you guys get to see it, and it's as I suspected, it does have our favorite little ticking time bomb. Since it's got no power, I'm going to concentrate on the power supply section and see whether I can get power. And maybe if I get power to it, we'll get something that resembles a picture. That is just a ground strap, so I can rip that out. There. Don't need it. Don't need it at all. Okay. Now we can see the inside of this thing a little better. Oh, there's a little switch in here. Wonder what that switch is for. Probably 50 or 60 hertz. This would be the power supply over here, I'm thinking. There's a main filter cap here. I don't see any fuses or anything on here. These wires are directly connected to this plug, and it goes onto this little board here. This is going to be the probably the rectifier board. We'll just apply power again and check for some more voltages. .27 volts. We'll go to DC volts. I'm going to check the voltage on the back side of this crap capacitor. 35 volts. Yeah, probes are backwards. So the AC to DC rectifier is working. Sure, a lot going on in this little camera for a black and white camera. Just shows how complex they used to be when CCDs were first developed. I mean, there's just tons of capacitors on here. Now, this may just turn into a teardown video. I don't know that I'm going to fix this or not. I'll take a look and see whether it's something that we can get going. But it may not be. I mean, it's not worth fixing. I can tell you that right now. It's not worth fixing. This is more of a let's take a look at it and see what we can do with this thing type of video at this point, whether it's something simple. I can pretty much assure you that every single one of these caps is going to be bad. But just look at the overall complexity of this little camera. I mean, you've got all the shielding that's got to come off just to get at anything. Just to see anything, you got to take off. And these boards do not plug in; they're all soldered together. So to do anything on here, you got to unsolder. Well, that one's got a plug on it, but these other ones are soldered down. I'm trying to take this base off, and there's screws everywhere. I can't get at these screws because this module's in the way. This should lift off, but it doesn't. Now if I take out this one bracket, I might be able to get the base plate off. And back in the day, this camera was probably quite expensive. I would think for a black and white camera, it's probably fairly high resolution. Okay, that goes out of there. Now can I take this bottom off? Yeah, okay, now I can take the bottom off of it. There's a DC to DC converter in here. You can see the transformer right there. And I'm going to just do some probing around here and see whether... That's probably what's not working. Well, I'll pretty much guarantee you that's not what's working, but why is what we don't know. Is it a cap that's bad? Is it a circuit protector that's open? Got no documentation for anything like this, so it's kind of a shot in the dark. Alright, first I'm going to measure and see whether there's any power getting from... I know I've got power on this power board, but am I getting anything down onto the main board itself? 1.2 volts. I should see like 35 volts here, I think. 0.5, 0.7, 0. I don't see any power getting down to this board from this main board here. What about if I measure on the cap itself? I don't see any power there either. Is this ground not connected? Let's just go, we'll just connect the ground lead right to the negative terminal here. And we see we have 35 volts there, so maybe this ground is not connected. Let's just see if we got power getting down to this board. We got power getting down there because I can feel heat. $35 volts. Yeah, I can feel heat over here. Where was I feeling that heat? Yeah, these parts are getting hot. There's a short on here somewhere, I'm sure. I don't measure any voltage, but it may be a different ground. Let's go to the other ground over here and see if there's anything over here on these capacitors. 1.6 volts. So there's power. And this is warm. Like this. This is hot to the touch. Like this is really quite warm. Just undo the power here. What's on the other side of this board here? These caps are hot. I wonder if they're shorted. They're hot. like they're really quite warm. I wonder if it got shorted cap, so that would certainly kill the power, wouldn't it? Let's just go over and look at resistance and just see whether. Yeah, 2 ohms, 2.5 ohms on a capacitor across a cap. It doesn't look good, does it? 1.8 ohms. I think we got to remove this one and see whether that cap has got a dead short across it. That's which one is that? That's this one right here. Is that a tantalum? No, maybe. Looks like, is that a solid cap? It looks like it could be a solid type cap. Doesn't have a vent on it, that's for sure. But that cap right there has got a short. We'll just remove it and see whether the short goes away. That'd be interesting if that's a shorted cap. Something else I noticed on here is that these are 2 separate circuit boards. See that? That's 2 boards. It looked like one, but they're actually 2 separate boards. They're held together with this bracket and a bracket on the other side. What is this thing? It is a 15 microfarad at 25 volts, and it is a solid cap. It's a Sanyo solid cap. And this was getting hot. Like this part was getting hot, so is this the one that shorted? Well, it's not measuring shorted now. But it was getting hot when it was when I put power to it. The leads were getting real hot, and this part was getting hot. It's still leaking though because it's a capacitor and it should not be measuring 11 mega ohms. This thing should be infinite. It's 15 microfarads at 25. I just wonder what happens if I just try applying power to this thing now with that cap removed. Got to fix my wire here that broke. That's what happens when you use solid wire, right? You bend it a few times and it tends to snap. But we'll just try powering this thing up without that cap in the circuit and see if I get a power light or anything. If the power light comes on, then we've made progress. Still no power light. Check and see if there's any voltage across that where that cap was. Yeah, 0.1 volts, so there's still nothing here. Probably still got a short across there. Diode might be shot. Let's see here. Across where that cap was, it is still got a 2 ohm short. So we still have a dead short somewhere on here. Next to that is the diode. And I bet it's shorted. Let's go to diode test here. Diode test. This is the diode here. Oh yeah. Yeah, it's shorted. I bet you that if I go to beep mode. Yeah, that diode's shorted. Okay, let's pull the diode and replace that and see if we get power. There's my diode. It's bad. Well, not as bad as it was before, but it's not measuring shorted now. So where's my short? 0.2. It should be. Yeah, it's bad. It's leaky. We've got We got leakage, right? I'll grab a silicon diode. We'll put that in. This will be a high-speed switching diode, I'm sure, but I don't think I'm going to have a high-speed switcher, but we'll try one. Well, we'll try what I've got. It won't last if I don't put a high-speed diode in, but I don't have one. What I can do is I can scope the transformer and see if the oscillator's running. So let's do that. Let's put the scope on. So this is where the diode came out. And we have, oh look, we got power. We got power from that, from the transformer. So we know that the oscillator's running. So I got a diode here. I mean, it's not the right one, but it probably will. Maybe it worked for a few minutes. It might work for more than a few minutes. It's not. It doesn't matter. The camera is not going to go back into service. I just want to see if it'll turn on. If I can get a picture of it for 5 minutes, then that's a success. If I can get a picture out of it for 2 minutes, that'll be a success. But I'm not going to spend any money on it, so I'm just going to deal with what parts I've got here. I can get this going through the holes. That's in. And I'll put a cap in there as well, obviously. I got a 47 here. We'll just put this one in. 47 at 16. Okay, we'll see if I get a red light when I power it up this time. No, I don't. I don't get any power. Yeah, I still got no power here. At 1.4 volts. I think it's supposed to be higher than that. And it's still getting hot. Like this is all getting hot. So somewhere we still have a short on here. Where that short is the big question. If I measure across here, I've still got, yeah, 2.5 ohms. Cap I pulled, it's also leaking. You can see the electrolytic leaking out of the bottom of it. It's not dead shorted, but it does have high leakage. In ohms mode here, we are at 1.2 mega ohms, but it's not dead shorted. There's still a dead short somewhere on this board. If I measure across where I pulled that cap from, we still got a 1.5 ohm dead short. So I think I'm just gonna wash my hands of this thing at this point, because every single one of these caps is gonna be bad. They're all gonna be leaking just like this. This thing's loaded with surface mounted caps. You know that they're gonna be bad, but even the through hole caps themselves, see, they're leaking. And this has got a dead short somewhere on it. I don't know where it is. It could be anywhere on here, and it's just not worth fixing. And that was basically given to me to throw out. So that is exactly what I'm going to do. I'm going to throw it out. But I thought you guys might like to take a look inside this thing. This old vintage look at the CCD on that. You can see the portion of where the image sensor is, and the rest of it is not even etched. Let's just check something out here. Okay, I got my short. Where's my short? 1.5 ohm short. And still short here. Where was it? Where was it I was testing? Oh, it was over here. Yeah. Got a short there, 1.8 ohms. I wonder what happens if I unplug this thing, this module. Is the short going to go away? Is the short in the module? Oh, yeah. Yeah, okay. There's where the short is. The short is in this module. I wonder what this module does. Well, what happens when we apply power to it with that module unplugged? Does the light light up now? Let's see here. Obviously the camera's not going to work without that module on there, but if the power supply lights up and doesn't have a short on it, then then we know. Make sure none of my wires have snapped off on the power supply adapter. And I still don't have any light, but that's probably part of the power supply. I'm sure this is probably another DC to DC converter that's inside this thing. But it has a short on it because the short circuit went away when I removed it. See, no short circuit now. 47K. Plug this module back in. One of the few things that actually unplugs. Plug the module back in, and Houston, we have a dead short. So the dead short is in this module. Let's open it up and see what's in here. Just for the hell of it, before I condemn this. Because this is going to get condemned. Something in here must create a lot of interference because they've certainly shielded it up well enough. Oh yeah. Yeah, it looks pretty crispy. Looks pretty crispy in here. What do you bet that transistor is shorted? And what do you bet every single one of these caps is bad? Let's just measure the transistor for shits and giggles. I bet you this transistor is shorted. Yeah. Yep, that transistor is bad. Shorted every which way. I mean, the board's all black too. So, yeah, this is a lost cause, this one. I mean, I figured that much going in that it was going to be one that was not going to be repairable. I just figured I would do some diagnostics on it and see where the problem is. This is a DC to DC converter. It's got two of them on here. You got one down here. This is one DC to DC converter. That cap looks like the top is bulging on it too. But you got one transformer here for whatever it's for, and that oscillator was running because we could see the waveform on the scope. So that one's running, and that feeds this one. The secondary DC to DC converter is generating multiple different voltages for, obviously, for different circuits on here. And although it doesn't look like there's a lot of different, looks like there may be. Well, there's at least two. I can see at least two different traces going. Maybe three. You've got a ground here. Those don't look like they have anything connected to it, but that one's got one. That one's got, yeah, maybe four different voltages on here. And input. Anyway, it's I don't know how many windings that transformer's got. It's got a couple. It would have a primary side, which is this side here. It looks like it's got two secondaries. So anyway, this is probably what generates the voltages required by the CCD, because I'm sure it requires, these older CCDs required multiple voltages. Kind of cool looking at that one, just the way it's you can see only part of the actual silicon is actually doing anything. This part here doesn't look like it's doing anything. It's kind of a cool looking chip. I haven't seen one like that. You can see all the little gold bond wires here. It would have been neat to get this thing running, but I didn't think it was going to be worthwhile doing anything when I first opened it up. We'll pull the board out here so you guys can get a closer look at what's on here, because this is going to be going in the scrap. So we'll just pull the board out here. So you guys can see how these early CCD security cameras were made. I mean, I've got some old ones too that are probably almost as old as this that are nowhere near as involved as this one was. Oh wow. Quite the complex. I mean, it's got springs and everything on here. What's that all about? That's probably the video cable there. But way too much going on this for what it is. I mean, just look at all this for a black and white camera. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9 circuit boards for a black and white camera. 10 boards. None of them plug in. They're all soldered down. So to do any work on this, obviously it's not designed to be repaired. And guaranteed, every single one of these bloody caps is going to be bad. If I get my ESR meter out, which I will, we'll just measure a few of them, but they're all going to be bad. Okay, that one's not, but that one's bad. That one's open. Put this one here. That one's open. That one's open. Yeah, I mean, they're all going to be bad. Every single one of these electrolytics is going to be bad on here. Guaranteed. This one here, I'm sure, is bad. Oh, that one might be the only one that's okay, but it almost looks like the top is popping on it. But what about this solid one over here that I was measuring before? Yeah, it's open. Oh, no. Well, it's not a very big one. That one's probably okay. That one's probably one of the few that are okay. Go to this board. .4. That one's open. 20. Yeah, see, they're all bad. Every single one of them is bad. And you'd never replace these. This is just a throwaway item. So I hope you guys enjoyed looking into this old camera. And I say it was not something that I was ever going to repair to begin with. I figured if I could just get it to run without doing much effort to it, then I would do it. I'll pull the parts out that I put in because I don't like to throw away new parts. So that's why I didn't. That's why I didn't solder them down to the board all the way down. I just kind of put them in there so that I could easily remove them, because I figured that this thing was not going to be repairable. So I don't like to throw away, new parts. So we'll just pop these ones out and recycle this, and we'll say thanks for watching. We'll catch you in the next one. Bye.